periodic law basically says that we can make some predictions on physical and chemical properties based on elements' position on the periodic table. And usually stated is that their properties vary periodically. In other words, they line up so that one column of compounds has similar properties, like we just said with the families and or groups. But anyway, before we start talking about the periodic table, let's get some definitions that'll help us explain some of these periodic properties. Okay, so factors that affect psi. First of all, the number of protons affects size, because the number of protons changes the nuclear charge, the positive charge in the center, and of course more positive charge in the center pulls the electrons in closer. But something new is what we call shielding. And we're talking about shielding of nuclear charge. So shielding this nuclear charge. And that basically says that it says that electrons kind of get in the way of that attraction of the outside electrons. Let's look at a picture. So what we're saying is that for this electron out here, the attraction it feels or experiences from this nucleus with the +3 charge is partially blocked by the electrons here. So their negative charge kind of gets in the way of the outside atom being attracted to that nucleus. Core electrons are electrons between the valence electrons and the nucleus. In other words, for this one out here, we always consider the ones on the outside. These two are what we consider core. So if the electrons on the outside, the valence electrons, are in the second energy level, then the core electrons are anything in the first. And you know, if our valence electrons are in the third, then the first and the second are considered core. Effective nuclear charge puts that together. It puts together the idea that you have a positive nuclear charge, but it is also partially shielded by the core electrons. And so we're going to subtract off the shielding by the core electrons. So that we see that effective nuclear charge is going to be pretty constant as you move up and down on the periodic table. And that's because as you move down the periodic table, there are more protons, so that would increase nuclear charge. But as you move down on the periodic table, there's also more core electrons, so it kind of cancels out. Effective nuclear charge increases as you move to the right on the periodic table, because as you move to the right on the periodic table, you have more protons and the same amount of shielding. Because as you move to the right on the periodic table, the inside levels are staying the same. You're having the same. Let's go ahead and add to this. Constant up and down, because up and down, let's just say down, you have more protons, but also more shielding. Also, another factor that we're going to use to explain things, and we already know this, the higher the energy level, the larger the orbitals are. So when it comes to atom size, more energy levels means more orbitals, but they're also larger. So you have a larger atom. Effective nuclear charge is going to increase moving to the right because you have more protons and same shielding, same core electrons. And so as you move to the right on the periodic table, the atoms get smaller. And that's the one, this is the trend that gets people, because they usually think as you move along on the periodic table to the right that the atoms are getting bigger, but they're not, because you're increasing the number of protons as you move to the right, but the shielding's remaining the same. So covalent radius is what we're going to call atom size. They're going to get bigger, atoms get bigger as you move down on the periodic table, and they're going to get bigger moving to the left on the periodic table within one row. Okay, and this one that I kind of starred and that we need to remember, it's not what we think. Atom size decreases moving to the right on the periodic table. These are the atoms in the main groups that are on the periodic table, and so some that you're very familiar with. Here's carbon. These are harder to tell, but carbon, nitrogen, fluorine, neon, in that row, that period, they get smaller as you move to the right. And again, it's because for all of these, they have their core electrons are in the first energy level, s orbital. They all have those as their core electrons. And so their shielding is the same, but their positive charge on the inside goes up as you move to the right. And so they get smaller as you move to the right. Remember that the position of the energy levels is not set. These shells vary in their size depending on what particles are in there. So if we're considering lithium, and we don't have that on this, lithium, and it's 3 electrons and 3 protons, like so, to beryllium, which has more nuclear charge, but 1 more electron also, the shielding is the same. These have the same shielding. And by shielding, I'm talking about shielding of nuclear charge to core electrons shielding. But the difference is the nuclear charge. This one has the and so it pulls the energy levels in closer. So it ends up being smaller, even though it has more particles. Another trend is ionization energy. Ionization energy is how much energy it takes to remove 1 electron from an atom. And we're talking about an electron in the outermost valence, in the valence shell. And it is harder. Because as you move up on the periodic table, the electrons are closer to the nucleus. And so as you move up on the periodic table, the electrons are harder to pull away, which means they have a higher ionization energy. Also, effective nuclear charge increases as you move to the right on the periodic table. Same reason as the last one, more protons, same core. And so those, as you move to the right on the periodic table, the electrons are harder to pull away. So ionization energy increases as you move up on the periodic table and to the right. Electron affinity is kind of similar. It's the change in energy to get an extra electron. And it's talking about how stable an atom is when it has an extra electron added. Interestingly, like when I talked about the ionic bonding, most atoms are more stable if you give them an extra electron, even metals. So these numbers are usually negative numbers, and when we talk about them getting larger, we're talking about, more negative, larger negative numbers. The fact that they're negative numbers is because a negative change in energy means you're going to a more stable place. Anyway, effective nuclear charge increases as you move to the right. And so that means that electron affinity will increase. Attraction to electrons increases to the right. And this is one that's really more complicated. There are all these little special situations that come into. So I'm just going to leave it with this one trend, that electron affinity increases as you move to the right on the periodic table.